Welcome to the Digital Amateur Television Experimenters Night. This is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania. Amateur radio is a worldwide hobby that has many different aspects. Digital television is just one of the many modes and areas that are covered. Maybe you're interested in becoming involved in the DATV Experimenters Nights. You realise that you do not have to be a radio amateur or need any ATV equipment to participate anywhere in the world. Also participate in the night by coming up to the Queen's Domain club rooms. Yes, right on top of the Queen's Domain in the heritage-listed Coast Wireless Station. You never know, we might get you in front of the camera or behind doing one of the many roles during the night. We get underway with our program on a Wednesday night from 7:30 p.m. local time. We'll see you soon. This is VK7 OTC.
Okay, this is VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania with our DATV Experimenters Night, and Justin, VK7 Tango Whiskey, at the microphone this evening. If you are watching on streaming, please let us know you're watching, and any questions as we go through, please pop them in the chat. Fantastic. Wish to acknowledge Tasmanian Aboriginal people as the traditional owners of the land upon which we present tonight, and pay my respects to elders past, present and emerging, for they all hold the memories, the knowledge, the culture and hopes of Aboriginal Tasmania. Now we've got a huge night tonight. There's been a fair bit going on in a whole range of areas. So the very first area I thought I would just give you a bit of a show and tell with is now how do we do this? If I do that, excellent. Now what we're looking at here is the screen grab that I took. I actually took today in the middle of the day, and what we're looking at here is 6 meters. So this is 6 meters whisper. 6 meters whisper was coming in from all over Australia today, and also Japan and a few other places. I think quite a few of the amateurs down here made contacts with Japan. But this one is only a VK5, so this is South Australia here. Quite strong, coming in at -8 on the whisper scale. But the thing I wanted to point out here is this is the magic band. This is the distance between here and here is 2 minutes. And so there's about half a minute, and then there is another half a minute, and then there is a block of about a minute in the middle here that has absolutely no signal. So first half a minute, we got a signal, and then it dropped out for about a minute, then it came back in even stronger for about half a minute, and that was enough for whisper to decode a -8 a -8 from VK5 ADE. So absolutely phenomenal, and I just thought I'd point that out. This is why they call it the magic band. For a whole minute in the middle of that 2 minute sequence, there was absolutely no signal. It drops out. Now this is the next one. Same story here. So we've got what we decoded was this is a VK2, so VK2 EFM, and in fact quite a not a terribly strong signal, but reasonably strong, -20. So -20 from VK2 EFM, and look at this. There is basically for half a minute, about a half a minute. That's still a 2 minute sequence here. About a half a minute, there was a signal, and it was enough to decode VK2 EFM. VK2, yeah, and that was the only decode for that particular time period. But -20 VK2 EFM. So there is the magic band in its demonstrating the magic band. Could not believe that. The reason I took a picture of it. So there you go. That's a good demonstration of the magic band in its glory. It's there for whatever, and if you can make a contact real quick, because they'll probably disappear as quickly as they appeared. Now we've got Andy 2E0REE. Hello Andy. Hello Paul. Hello Andrew. And yep, Andrew's coming in from Kettering. So his new QTH in Kettering. So what we'll do now, I will attempt to. Now how are we going to do this? If we do this, we'll go across. Ah, look at that. That's excellent, excellent, excellent. Now, in a little while ago, I frequent some of the auction sites around the place, and there happened to be a lot that had this particular cover, just the Kenwood bit of the cover sticking out of a bag, and I didn't have time to go and actually have a look at what the rest of it is, but I recognised it as a Kenwood ATU unit. So what I thought we might do is we'll have a bit of a look at what's inside. Now, this is the MAT-100, and if I zoom down a little bit, you'll see there were two things in the bag. There was the ATU, which was sticking out the bottom, at the top of the bag, and then sticking out the bottom of the bag was a Kenwood TRC 70 SSB radio telephone. Now this is a synthesized rig, comes up with, I think it's got 99 channels. It's HF, so it's 3 to 30 megs. In fact, it's 1.8 to 30 megs because it covers. It's a marine HF transceiver, 150 watts, and so very nice rig, and it works. I have plugged it in. I've plugged in the power, etc., etc. Now I wasn't actually that interested in the rig, but I was very interested in the ATU. Now the ATU is the matching ATU for this particular rig. Basically, on a boat you would have a mainstay or something like that, and then you'd have a long wire off the main mast to the back or the front of the boat, depending on what configuration you've got. You'd have your perfect ground in that you'd have a connection to the keel or a plate or something on the side of the hull that has a wonderful connection to salt water. And then you'd have an antenna tuning unit, which is connected via a multi-core cable to the transceiver, and then you can go through and press the tune button on the transceiver, and it will automatically tune. So it was actually the ATU that I was interested in, because this is effectively a HF ATU. This particular application is marine, but I can certainly redeploy it for HF amateur bands. So I had a bit of a look at this. I thought, well, it's a little bit dusty, and the The thing that's actually missing here, as you probably notice, is the seal around here, the rubber seal that goes around here. There were no screws in the top, and it's obviously been open for a little while. And I thought, oh, this doesn't bode well, because maybe there's something wrong with the ATU. So I plugged it in, put some power on it, and then put it into a tuning sequence with a dummy load on it, and it seemed to go through a tuning sequence really well. So I thought, well, this is a bit of a win, because I bought both of these, I think, for something like about $120, and I was really only interested in the ATU, and I'll probably sell off the marine radio. But just thought we'd have a bit of a look inside. This is pretty stock standard. If you buy any sort of LDG or a Yaesu or ICOM, they all do the same thing, and they all look very similar. You've got your connection to your wire or your antenna up the top. Quite a decent insulator through the case. Comes in, goes through an SWR bridge here, so it's giving you the standing wave ratio back into the electronics. There's some analog to digital conversion. There is a CPU that sits in here under this, and all RF protected. There is a whole lot of configuration dual inline switches here where you can set up particular things. There is a E2 ROM memory in here, so it can remember. You've got obviously your lower frequency inductors, and go higher and higher in frequency to get your match correct, right up to quite small inductors over here. There's a whole bunch of capacitors, so one side is the inductive side, and one side is the capacitive side, to try and match what's sitting up here to your 50 ohms, which is down here inside the case. So you actually have to take the case off to unscrew the SO239, the PL239. So you've got a whole bank of relays that flick through, and you've got a whole bank of relays here which flick through and supply a variety of capacitances here, so that combinations of your inductor and your capacitor give you your matching network, so that this looks something like about a 50 ohm load down here at your input. So I just thought I'd give you a bit of an inside view. You don't get to see inside antenna tuning units very often, but it's beautifully made. It is labelled up as a Kenwood device. I don't know whether it's a rebadged device, because it looks very similar to a lot of the other antenna tuning units, and in fact there doesn't appear to be a Kenwood logo on here anywhere that I can see that's obvious. So it may be a repurposed one from ICOM or one of the other manufacturers. So anyway, there's an antenna tuning unit, an MAT-100. Very nice little unit. It will be pressed into service, and it's all. This usually sits outside, so this is all waterproof. All of the connectors are waterproof, so that there's no water ingress in through the various holes in the case. But anyway, Kenwood MAT-100, an automatic antenna tuning unit. Absolutely fascinating. Now, what I will do is I did print out the specifications of that particular unit. 1.6 to 30 megs, 150 watts PEP, 100 watts continuous, and 50 ohms impedance, obviously. VSWR of less than 2.0, so once it gets down below 2.0, I suspect the tuning stops, which is a bit of a pain. You can't manually change that, but antenna required, 7 to 23 meters of wire, 23 to 75 feet, to tune from 2 until 30 megs, or a 2.7 meter or 9 foot whip, which will give you a tuning range of 3.5 to 30 megs. So tune-up time is somewhere between 2 and 15 seconds, so it's pretty quick. Requires 13.6 volts, negative ground, maximum of about 2 amps, and I don't think they're latching relays, so you would have to go through a process of, if you remove the power, you'd have to go through another tuning process, and everything is waterproof and weatherproof, and you've got a 5-core multi-core cable that you've got to connect between the rig and the antenna tuning unit. So there you go. Now we've got oh, hello, ZL4KEN, Ken, KENZ, hello, Ron, hello, on RFN stream, and Andrew, I remember pulling coaxes for one of those buggers behind the bunks of a 70-foot yacht. Oh, I love it. Grounding was a 2-inch copper strip down to through the hull electrode. There you go. So absolutely perfect ground on a yacht. That's one of the advantages of you being on a boat. The electrolyte that is seawater is absolutely fantastic. Can't remember if it was the mizzen backstay or one of the main mast shrouds up to the first spreaders that was split into insulators and used as the antenna. Yeah, okay, that's a pretty common configuration. Fantastic. They were made by Kenwood. Okay, Andy, thank you. They were made by Kenwood in the UK, so United Kingdom. So fantastic. Thank you for that. That's great. Really well made. Really, and it's still working. I had this horrible feeling when I opened the bag and I found that the two sides of the case were open. I sort of went, oh, this is just not looking good. Why have they done this? But everything seemed to be okay. Then I realised that you actually had to open the case to unplug everything and unscrew everything. So whoever removed it lost all the screws out of the case, lost the rubber seal around it. But we can make up other rubber seals, so that's not a loss. But anyway. Nice find, and it definitely didn't cost me anywhere near what the original price was. So there you go. Okay, now what I would like to show you now. I'll just do a bit of a reconfigure here because we just. Our walk in the Black Forest, I've just got to make sure that our camera, just bear with me, we haven't quite got our, there we go. Okay, so what are we looking at here? Now, I've been banging on over the last few weeks. This is the TNC-Pi. So this is the terminal node controller board, the hat for a Raspberry Pi that sits underneath. There's a Raspberry Pi 3 that's sitting underneath this. It is connected via the DB9, which is where all the control signals and the RX and TX signals come out of, and it's connected into the speaker mic connection. And I'll go into speaker mics in a short while. That was actually a real headache because I was thinking way too logically, and speaker mics are not logically wired. But anyway, and I've also got there is a little screen here which I'm not using right at the moment, because what I can do. There we go. There we go. Now. This is the output from the TNC-Pi. It is running a Java application called YAAC, Yankee Alpha Alpha Charlie, which is yet another APRS client. And it was created by Andrew Pavlin, who is KA2 Delta Delta Oscar, KA2DDO, and he is still supporting this. It was created back in, I think, 2014 from memory. I think that might be right. I might have got that wrong. But he's created a wonderful little Java application, APRS Client. Now, for those who don't know, APRS, Automated Position Reporting Service. This is a application that was created by, unfortunately he's silent key now, he died a year or so ago, Bob Bruninger, who is WB4APR, Alpha Papa Romeo, who created the APRS system. It is a multicast packet radio system. The whole system is based on a one-to-many type of transmission. It is very lossy, but there's lots of redundancy built into the system. Lots of digipeaters. So digipeaters are things that take the packets it hears and then repeat it or parrot it back out again. Lots of digipeaters. There are lots of what we call I-gates or internet gateways. So they hear packets through RF, and they are connected to the internet, and they transfer that information onto a whole network of APRS servers around the world. It is simple ASCII text format, so nothing special, no encryption, no nothing. You can see what's going past, everything that goes past. Really short tactical packets, so that's more likely that you'll get those short tactical packets through rather than large streams. There's a lot of redundancy, there's a lot of error correction, there's that sort of thing built in. Many of the things that we use on APRS, we track trackers for public service events. So we had a equine endurance event where we had backpacks being worn with APRS at one point. The system of RFID tags that the Northern Tasmanian Amateur Radio Club use, where the rider comes up to a checkpoint and they swipe their RFID tag. That is all transmitted into one of these TNC-Pis and a Raspberry Pi through a radio, and that goes back to base, and they log when that rider goes through, the time, etc., that they go through that particular checkpoint. So it's a very similar arrangement to what we're seeing here. There are weather stations, which are weather reporting stations, which APRS out that weather information. There's text messaging between nodes that's available. There's bulletin boards. There's local information, or QRU, where you can query for particular locations. At particular locations you can query the APRS server, and it gives you things like frequency and offset of repeaters and all sorts of things. Satellite communications. There's satellites that are going around the world that have got APRS transceivers on them, TNCs, etc. And there's also a D-Star has what they call DPRS, which is D-Star position reporting service, so that links into the APRS system. So there's all sorts of things that you can do with this particular APRS system. Now, YAAC, what you're seeing on the screen right at the moment is the OpenStreetMap view that YAAC gives you, and what you're seeing here is we've got the handheld here, which is probably not receiving very much at all, I have to say, because we're in a shielded building, and we're also, there's a whole lot of other RF sources around here which is probably making this terribly deaf. But you'll see that through the internet, because this is also connected, this Raspberry Pi is connected to our Wi-Fi here. It's also bringing up, and if I head in here, this is a bit tricky because if I head in here, I just zoom in a little bit here. This is where we actually are right at the moment. this is at the Queen's Domain, VK7RAD, RADR, which is RADB, sorry, so that's saying it's a beacon station up here. And then over here you can see this is the, oh, it sort of disappeared into the detail of the map, but there is a VK7TW-2. We've just zoomed off the map. Let's bring that back onto the map. I'm doing this remotely. A mouse in front of me and a screen that's next to me. So VK7TW-2, South Hobart. In fact, that's this one, which is not quite strictly true, because of course we're up here. It's still got the long and latitude, the longitude and latitude for my QTH at home that's beaconing out there, but so that's not strictly true. But you can also see there are a range of other stations around Hobart. If somebody had the APRS tracker in their vehicle, then it would be picking up that stream and showing it on the map. Let's zoom in a bit more. You can see there's Danny up here at Gagebrook, VK7HDM. There is VK7ZRO with a digipeater up here and an iGate up here. There is those two. There's VK7HSE, who might even be on the stream. No, maybe not. VK7MBD, so that's Bruce down the channelway. And there's a few APRS beacons that are coming out there, MBD 1 and 2. VK7 REC, I don't know whether that's quite right, but anyway, REC probably is. And you can see they're appearing on this map. Now, this is also, what I've done is configured this as a digipeater, so anything it hears, it repeats it out after that. This is also an iGate, so anything it hears, it shoots it off to the internet. And you can see up here in the control bar up here, there is a little RF and a IP. Every time it sends something out to one of the APRS internet gateways, there we go, there it goes again. And if the RF triggers, and if I do a beacon, let's do a beacon here, I'll click the beacon and... Oh, I would have thought that would have beaconed. Maybe not. Ah, the RF goes red. Oh, there we go. There, it's just a little bit delayed. So it's just beaconed out the APRS information, the long and lat, and a little bit about what's this this particular TNC is capable of. So that's just beaconed that out. The go and stop buttons, the green and the red there, that's another little feature. You can shut things down or start things up right then and there. Now, what I was going to try and show you here, now this might be fraught with a whole lot of problems, but anyway, let's go. This is live television. So now, if we go to the configure menu and buy wizard. Hang on, let's go down. This is difficult. Okay, buy wizard. We'll click on that. Now, this is really easy to install. If you follow, there are some great instructions on how to follow it. And literally, once you've got it installed and opened up, you can go through and you can see into the station call sign. It's VK7TW. I've got it as -2, which is just a generic additional station. So I don't have to change anything here, but this is the configuration wizard that takes you through all the things you have to configure. Specify what the station type is. I've got a digipeater or iGate checked. I've got the symbol that I want appearing on the map, and there's a whole bucket load of symbols that are available to you there for different purposes. Haven't got the region code, don't need that, so we'll go to the next screen. Okay, this is the longitude and latitude. Now, the TNC-Pi and the YAAC software support a whole lot of GPS inputs. You can plug one of those little GPS dongles into the USB, and it will start taking the NMEA feed from the GPS module, and it can dynamically update this. So I could have this in a car and actually have the GPS updating and it beaconing out my position in the car. In fact, this is very similar to the arrangement that's in the my vehicle, except I use a little tiny tracker, not a TNC-Pi. You'll see here, show the messages from stations. Oh, there you go. There you go, Andrew. Will the live demo gods allow this? Yes, it will. Oh, very good, Andrew. I love it. I love it. I love it. I love it. So there you go. That's I did sacrifice the goat earlier. So it's showing you the messages, the live messages. That's a good demonstration. I love that. Thank you, Andrew. I literally haven't got a GPS module on here because this is usually at home and it's in a fixed position. So I've put in the longitude and latitude, which is why it appears in South Hobart, not here. I probably should. Oh, there you go. Thank you, Andrew. Yes, it is working. This is the live demo from the studio. So we now go to the next configuration screen and the next one. Now this is the important one. This is where you set up your ports, and you'll notice there are two ports set up here. The first port is the serial TNC, which is on one of the serial ports on the Raspberry Pi. That's the connection to the TNC-Pi. The second port that I've set up here is to APRS-IS, which is the Internet Gateway, and you'll notice it is AUNZ APRS.APRS2.net, which is our regional APRS server. You need to go to the author of YAAC to get access, and you need to prove that you're actually an amateur to Andrew. And once you've done that, he'll give you a passcode and an address. So you can then start feeding and receiving things from APRS. Oh, hello, David Bannister, watching from work. Well, there you go. I love it. So you set up those ports. This is also where you would set up if you wanted a GPS coming in through one of the USB ports. You would set up another port in here. And start taking the NMEA feed from the GPS module. Now the very last bit, the configuration, we enable the station beacon. I've got some free text in there which says Digipeater and iGate at South Hobart, and literally that's about all you need to do to do at least an initial setup and get your TNC-Pi up and going on APRS. And you can see it's beaconing out there. It's on the map. If you go to aprs.fi, which is the main display of APRS traffic around the world, then you can certainly see it appear and see the traffic that's coming to and from. You can set up the iGate so that it is only one way. It's only what the TNC-Pi hears, and then it sends out to the internet, to the APRS servers. If there is another iGate that has received your signal, that same signal as you, it will ditch the later reports. It will only take one report and report that out. I think there's in APRS version 1 there was a bit of an issue where you could actually end up in a bit of a loop with multiples, basically digipeating out themselves and getting themselves into this great big digipeat storm, and loading up all the channel RF channels. That's all been fixed, so there are some thresholds and some limits in there. But so now the other thing I wanted to show you was there was somebody, Jim VK7JDZ, today was up on Mount, activating Mount Marion, and somebody, and I'll just go to, if we go to here, and to here. This is a screen grab of my the TNC-Pi when it was at home, and you notice VK7JDZ is around about where Mount Marion was. I think somebody was shooting out a spot for him. It appears that APRS Droid sends messages again if you let the phone sweep and wake up. Oh, well, there you go. Oh, well, there's some learning for you, Andrew. But somebody was beaconing out Mount Marion, and also if we zoom in here, you'll notice that there is a PE1. There is a PE1RXJ. So this is a Danish APRS, and if I clicked on the APRS, you'll see it's got the phone symbol. Somebody was APRSing out via their phone. It was Android APRS Android, and it seems that a Danish amateur PE1RXJ was in Hobart today and went up to Mt Wellington, because I followed their trail up to Mt Wellington, and there you go. So I'll come back to here. So that's a little bit of a hint of APRS, automated position reporting system. Really easy to get into. The TNC-Pis are available from MFJ now. I bought them when they were the original company, but the original companies then passed that on to MFJ, and they're producing a surface mount one. It's a kit, you put it together, so it comes with all the bits and pieces you need. So anyway, that's a bit of a look at APRS. One final look at the map, and yeah, it's absolutely fascinating. And what you can do with it is just off the show. I'm sure there will be future episodes on APRS. So there you go. Now, okay. With this wonderful little arrangement that I have here, this looks all very tidy. It goes into the 3.5mm and the 2.5mm stereo plug, and for those who don't know, I'll this is an ICOM HM-46 speaker microphone, and you'll see there is a 3.5mm and a 2.5mm stereo, so 3.5mm mono and a 2.5mm stereo connector that plugs into. Many handhelds have that particular arrangement for speaker microphones, and let's come back to here. Oh, hang on. What just happened there? Oh, that's better. Have this arrangement for speaker microphones, and so through that connector you have to have obviously the speaker connection, the microphone connection, and the push to talk connection. Now I thought, oh, this is a piece of cake. there are 3 connections on here and the relevant grounds. So one will be microphone, one will be speaker, and one will be push to talk. Oh, was I wrong? So when I was originally using a ICOM IC-2GAT, which is a much older handheld than the T90A, which I'm using here. Same microphone though, and same connections, and I wired it all up, and it could receive. That was great. No microphone, no push to talk, and I went, what's going on here? Then I started doing some research on the net. Boy, was I wrong. The arrangement they do with speaker microphones is off the show. So, a HM-46. Basically, the 2.5mm stereo socket is ground, microphone ground, 5 volts, because it's an electret microphone. So you need a voltage, and then there is microphone and push to talk. And I went, oh, how's this work? And now the speaker, the reason the speaker worked was the 3.5mm jack is just a straight out speaker connection. Fantastic. So I started doing some investigations, and I looked at the circuit diagram. Let's zoom out here a little bit. The circuit diagram, I don't know how well this is going to come up, but anyway, I'll point out the salient features. When I had a look at the stereo microphone socket here and the mono speaker socket, okay, speaker socket, that's fine, comes straight out of the amplifier, the IC amplifier, straight out to the speaker. That's easy, piece of cake. Then I started looking at the microphone and push to talk. Now, the 5 volts comes out of the circuit, comes down here. There's a little bit of regulation and a little bit of current limiting just here, that then goes off to the center pin of the 2.5mm jack. Okay, so that's purely only voltage. Not going to get anything off of that. And that was what I was connecting to the push to talk. Now, the microphone goes off to the first transistor amplifier here. Okay, so that's pretty normal. So inject this in and it goes off to this amplifier here. But when you go down here, it also goes down to the actual microphone that's in the unit, and the other side, the microphone here, if you trace out this circuit, which is in orange here, it also goes up here to the push to talk switch, and the push to talk switch grounds that particular line when you push the push to talk. So what effectively you're doing is you're supplying a ground to part of the circuit, the other half of the microphone here. And I thought, how the hell does this work? And then I realised, I suddenly realised that what they do, and I came across a wonderful website, G4WPW over here, and he talked about this. So that middle pin has got the voltage on it, this has got the microphone on it, and if you trace this out, the push to talk actually takes the ground from here and supplies it to the microphone ground here. And so the circuit detects that resistance changes, and it says, they've pushed the push to talk, and then they initiate the push to talk. Plus, it also supplies the ground for the microphone. So, once I did a little bit of playing around, and there is now inside this particular plug, actually no, I put it in the DB9 because there was plenty of room in the back of the DB9. There is a little 33 ohm resistor between the push to talk and the microphone connection, and it works an absolute treat. So and when I started looking at other other microphones, speaker microphones, and there are a plethora of them out there, they are all different. So this one just happens to work with my T90A and my IC-2GAT because it happens to be the same circuit. But if I plug that into another one, like a Baofeng or something like that, or a TYT, I don't think it will work because they actually have a different circuit. So, oh my God. Be aware that speaker microphones are not just simple three connections. They do some tricky stuff. So just be aware of that. I put in the title of this particular night, Headache and Headaches, and that's the headaches that I've actually had. But once you work that out, it works an absolute treat. This will eventually. I won't be using the T90 the T90A permanently. I'll actually be using a PRM 8030, which is a 25 watt unit, and marvelously that just plugs into a DB15 on the back of the radio, which is really convenient. So that's what I'll be using, and also be putting out 25 watts whenever it beacons. Right at the moment, it's putting out about 5 watts, and I have it on a much better antenna at home. So anyway, that's speaker microphones. You got to be kidding. they're not as simple as you think. So now membership renewals. Membership renewals for Reast have been sent out. Go into Tidy HQ, and there's a link in the email that would be sent out. And you can renew, or if you've set automatic renew, it's probably already renewed you for the year, for next year. And a reminder that overseas memberships are available. They're half price, so 4 cups of coffee get you an overseas membership. So if you're thinking about it, I know there's some people on. Lionel's one of them, KJ7OFH, and I'm late. Okay. Oh well. Catch up on the stream. It's available on the YouTube channel. So yeah, Lionel, we've been looking at some tricky stuff to do with APRS, and you need to catch up on that with the stream. So APRS are using a Raspberry Pi and a TNC-Pi hat. So really impressed with that little hat, and the software just works. I absolutely love it. Very little stuffing around. All the stuffing around was to do with the speaker microphone, and oh my God, so that made up for all the stuffing around with the software. I'm going to have to watch the start again about the APRS. Okay, that's Colin. Hello Colin. Very good. So just a reminder, we are doing ATV, DATV nights throughout the silly season, all the way through December and also into January. So we'll be around, we'll be on the stream, and our first presentation night, which will be streamed hopefully, is on the February the 7th. It is a presentation about the Surf Lifesaving Tasmania radio network, which is all around Tasmania, given to us by Greg Bird. So thank you to Greg for jumping in and giving us that presentation. Really good. And Sunday, February the 18th, is the Reast AGM and special general meeting. So annual general meeting and special general meeting. That's a really important one. There'll be a barbecue after the broadcast, and then we'll head into there'll be an AGM, SGM, then into a barbecue on Sunday, the February the 18th. So there you go. Now, our new segment, Australian Space Weather Report. There are absolutely nil warnings on anything. So, I hope that no HF comms warnings, no HF fade warnings, no geomagnetic warnings at all available on the Space Weather Forecasting Service. So the ionosphere is in half reasonable condition. So go out there and create some RF. 20 metres was certainly good today. I was listening on the loop and playing a little bit with the magnetic loop. So 20 metres was well and truly open, and lots of people coming in from UK and the US. So So good stuff. Anyway, that's our show for tonight. This has been VK7 OTC, the club station of the Radio and Electronics Association of Southern Tasmania, with our DATV Experimenters Night. And we'll see you for our Christmas edition, which is next Wednesday night, just before we break. And then we'll have a post-Christmas edition when everybody's on holidays. So it'll be a very festive and relaxed DATV night. So we'll see you next Wednesday night, 7:30 local time, on streaming and RF and a variety of other methods. 73 people.